Alright, so today in pre-calculus we will definitely be talking about hyperbolas. Okay, a lot of stuff going on here. Axis of symmetry right here. It will be going through the middle of the two hyperbolas. So it's horizontal right here, it's vertical right here, and it's just going to be along there. Now obviously we can have it different at different places and stuff, but the axis of symmetry is usually equal to whatever the h and k are, depending on whether it's a horizontal or... Alright, now the center of the hyperbola is just going to be this bad boy right here in the middle. Okay, so pretty simple stuff. That's going to be the center of the hyperbola. Alright, now the conjugate axis is going to be the one that goes right down the middle. So the conjugate axis is going to be right there. So it goes right down the middle here and right down the middle here. Okay, now the focus of the hyperbola is definitely going to be inside the two hyperbolic shapes. Okay, the actual hyperbola itself is drawn, and I try to draw it with the asymptotes so you can see that it requires the asymptotes to draw it. It's not just two parabolas going in opposite directions, although it does look like it, but it's these two hyperbolic drawings. Okay, now this one, obviously the blue one in blue is not as well drawn, but it actually does work the same way. Okay, the one in red is probably pretty close to exactly what a hyperbola is going to look like. Okay, alright, the vertex of the hyperbola is definitely going to be in the two centers of the hyperbolas. Okay, and then the horizontal and vertical formulas are right here. As you can see, they're very similar to the previous section where we talked about ellipses, except c squared equals a squared plus b squared here, and the asymptotes are actually found by these two sets of formulas here. Okay, so without further ado, let's talk about what a hyperbola is. Now, an ellipse was the distances from any point to the focus plus the distance from that same point to another focus, and we added them, we would always get a constant. Well, here it's subtracting, and so this will always be constant. So if I pick a point here, okay, the distance from here to here, and then subtract here to here, that is going to be the same as if I found a point here on this hyperbola and then took this distance and then minus this distance. So those two distances would both be the same when I did the subtraction. Okay, and obviously, as you can see, the straight line's a lot better. Okay, alright, let's start practicing some stuff. Alright, let's find the equation with foci at 7, 1 and negative 3, 1 whose transverse axis is 8 units long. And let's talk about the transverse axis. Okay, the transverse axis is going to be the same as the axis of symmetry. Okay, so the transverse axis, now here's the thing though, is that it's the connection point between the two. So let's go back. Okay, so the transverse point axis is just like the actual, I guess, axis of symmetry, but it actually just goes from vertex to vertex. Okay, so that's 8 units long. Now, if we take a look at our formula sheets for that, the transverse axis will actually tell us the length of either a squared or b squared. Okay, so the transverse axis is going to be 2 times a, that's the length. Obviously the conjugate axis would be 2 times b. Okay, so 2 times a is that, and so what do I get? I get a to be equal to 4. Okay, so that gives me a. Now, here's the interesting part. The foci, if I do the midpoint formula on these 2 points, I should be able to find the center of the actual hyperbola. Okay, so the first point will be 2, because 7 plus negative 3 is going to be 4, and 4 divided by 2 is 2. And the second point is going to be 1, because 2 divided by 2 is 1. Okay, so this gives me actually my h and my k. Okay? Okay, now this is the point where I would say, oh, uc squared equals a squared plus b squared. And you're sitting there going, oh, we have a, so we can replace that with a 4 squared, which is 16. Okay, but here's the tricky part. We don't know what c is. But if you remember, if you go back to the foci are going to be the amount of units away from the center. So if you notice, okay, the ones are all the same, so that doesn't change. And as a matter of fact, this is actually going to be a horizontal okay, dealing with a horizontal type of hyperbola. Okay, but the distance between the 7 and the 2 is 5, and the distance between the -3 and the 2 is 5. So that has to mean that the foci, that C has to be 5. That's what I had to add to this part right here to get the actual foci. So I had to add 7 and then subtract, I had to add 5 and then subtract 5. So now I know that this is going to be 25, and I can use it to figure out that 9 is going to be equal to b squared, which means, 3 equals b. Okay, now that I know all this stuff, I know HK, I know A and B. Okay, I need to make sure that the since it is a horizontal, that x needs to come first. So this is going to be x minus 2 squared. Okay, and then we're going to minus y minus 1 squared, and this is going to be equal to 1. Okay, and then underneath this one we're going to have the larger number, which is going to be the 16. So the 16 here, and under this one we're going to have the 9. Okay, and voila, you have the, now this is going to be the general form, this is going to be the standard form. If you wanted the actual general form, you would need to multiply everything by the common denominator and then work your way across. Okay, and that's what we're going to do right here on this one. Okay, so the pertinent info we can get from this is only done if we can transfer this to standard form and not general form. So first off, group everything together and factor out the common terms. So when we put everything together, we're going to have the 9 in the front, and we're going to factor out of x squared and negative 54, which is going to leave negative 6x. Now you're going to complete the square by adding 9. Okay. Makes sense. Now this one you're going to factor out a -4 because it is a hyperbola and we do need a minus sign in between. So we're going to have y squared plus 10y plus 100. Well, 25. Need to do my math real fast. Now I moved the 55 over to the other side. Okay, now I'm going to add the 81 because it's going to be the 9 times the 9, so I add it to the other side as well. But here's the tricky thing is, I now have a minus 4 and a plus 25. So technically that's a minus 100. So I need a minus 100 from this side as well. Okay, and you'll see why in a sec. So now that I got that all done, we're going to rewrite it in its factored form. So 9 parentheses x minus 3 squared minus 4 times y plus 5. Sorry, I had too many parentheses up there. Okay, and this is going to equal 36. Okay, and what we do is divide everything by 36. So when we divide this by 36, it's going to be 9 over 36, which reduces to 1/4. And when we divide this by 36, it's going to be 4 over 36, which becomes 1/9. Okay, and voila, we have everything that we need to set up. Now, do we need to actually find everything? Yes. So C is going to be equal to 81 minus 16, which will be the square root. So that's going to be, I think, 5√3, which is 75. 81 minus 16. Nope, that should be 65. So that will be, yep, just the square root of 65. Okay, so that's what C actually is. So when we write it out, we should have the foci be equal to, now if you notice, the x comes first. Now I improperly said that the bigger number always goes underneath the number on the left over here, and I just realized that when I was working on this. I was like, oh, no, there's no way that can always be. It's just wherever the transverse axis is. So technically this one is under the bigger one, but this is still a horizontal. So you just have to be careful to look at the math and look at what the transverse axis is doing. And the transverse axis goes it does go from vertex to vertex in this one, but in this one it's going to be going up and down. It's going to be the longer of the two axes. Okay. Alright, so the foci here are actually going to be, let me see, so that's horizontal. So the center is going to be 3 plus or minus, square root of 65, comma, -5. So that's going to be the foci. The center is going to be 3 comma -5, so that's pretty simple. Okay, now the asymptotes is what we're going to actually get from this. Okay, so the asymptotes, if you remember your formulas, okay, so since this is a horizontal, okay, so our asymptote's going to be right here, so it's going to be b plus or minus b divided by a times x minus h plus k. Okay, and so in this one, b and a are going to be, let me see, a always comes first, so a will be 2, so the asymptotes will be equal to, well, it's actually going to be a line, so it's going to be y equals plus or minus, what is it, b divided by a? Okay, so that will be 3 divided by 2 times x minus 3. Well, it's going to be minus 5. Well, 1, 2, yeah, minus 5 right there. Okay, and voila, you actually have your lines for your, you have your equations for your asymptotes. Okay, now as we tie up the conics, obviously we haven't talked about parabolas yet. I wanted to show you the eccentricities. Okay, all right, so here's another way to get the actual formulas. This is another calculation right here. All right, now for eccentricities greater than 1, we get a hyperbola. Okay, all right, so when you're taking a look at that, just be careful just to take a look at it and go, okay, this is what we're talking about, this is how we're working with it, and this is how you identify the eccentricity of a line. Okay, so here's this formula here. There might be different formulas that you find, you're allowed to use them, but just know that there's always a formula to help you find the eccentricity of the conic. Okay, all right, and just to summarize, eccentricities equals 0, we get a circle. Between 0 and 1, we get an ellipse. Okay, and greater than 1, we get a hyperbola. And next time we will talk about what happens if you get it equal to 1. Okay, I'll talk to you later. Bye.